Ready for a deep dive into the latest cybersecurity news? Straight for the research labs, we're looking at some brand new papers on arXiv, and they cover a lot of ground. Critical infrastructure security, AI-powered defenses, even the changing threats around large language models.
Yeah, it really is a constant back and forth between innovation and vulnerability. And hopefully after today's deep dive, you'll have the knowledge to stay one step ahead.
Sounds good. Let's jump right in to a topic that affects us all, cybersecurity, specifically the cybersecurity of essential infrastructure.
Right, so researchers are really starting to sound the alarm about operational technology networks, or OT networks.
OT networks.
Yeah, these are the systems that control our power grids, factories, water treatment plants, basically all the things that keep our modern society running. There's a new paper that takes a deep dive into all of this. It's called Cybersecurity of OT Networks, a tutorial and overview.
So these OT networks, they've been around for a while, right? What's changed recently? Why are they suddenly so vulnerable?
It's a good question. The big change is the convergence of IT and OT systems. As we move toward Industry 4.0 with its cloud connectivity and remote access, we're inadvertently creating more and more entry points for attackers.
More doors for attackers to get in?
Exactly, like adding a bunch of internet-connected doors to a fortress that was previously isolated.
And what could happen if an attack on these OT networks was successful?
Well, the potential consequences are honestly pretty scary. Think widespread blackouts, from disrupted power grids, production lines grinding to a halt in critical industries, and maybe even compromised water treatment facilities, which would be a huge public health risk.
And this isn't just hypothetical, is it?
No, unfortunately not. We've already seen real-world examples of attacks like this actually happening and caused a lot of damage.
That's a scary thought. What are researchers doing to try and mitigate these risks and keep these vital systems safe?
Well, the paper highlights a few key strategies. One is network segmentation, kind of like creating internal firewalls to contain any breaches. Then there's robust intrusion detection systems, like having really vigilant guards. And threat intelligence sharing, where organizations share information about potential threats to strengthen their collective defenses.
It's like a never-ending arms race.
It really is.
Well, speaking of arms races, let's talk about a powerful tool that's being used in both attack and defense these days. Artificial intelligence.
Ah, yes. AI. It's definitely a double-edged sword when it comes to cybersecurity.
How so?
Well, on one hand, there's a paper called CND-ID's Continual Novelty Detection for Intrusion Detection Systems, and it talks about how AI is being used to build much more adaptable intrusion detection systems.
So instead of relying on static rules that attackers can learn to bypass, these AI-powered systems are always learning and evolving, becoming more effective at detecting new threats.
Exactly, like an immune system for your network that's constantly adapting to fight off new viruses. This research actually showed that these AI systems could be something like 30% more effective than traditional rule-based systems at identifying those unknown threats.
That's a huge improvement. But what about AI's role in detecting hardware Trojans, those little bits of malicious code, hidden inside computer chips?
That's covered in a paper called SALTI, Explainable Artificial Intelligence-Guided Structural Analysis for Hardware Trojan Detection. It basically talks about how AI algorithms are being trained to analyze the structure of computer chips, looking for anything unusual that might point to a hidden Trojan.
AI detective, looking at microscopic circuits.
You could say that. It's all about pattern recognition. On a massive scale, these AI algorithms are trained on huge data sets of both clean chips and Trojan-infected chips, so they learn to spot the subtle differences and then flag potential threats with amazing accuracy.
But even if AI flags a potential Trojan, but we still need to understand why it did that, it seems risky to just blindly trust a black box, especially in an area this important.
I completely agree, and that's why this SALTI research really emphasizes explainable AI. They're actually developing techniques that can provide insights into the AI's decision-making process so human analysts can understand exactly why a certain part of a chip was flagged as suspicious.
Transparency and accountability are so important, especially when we're talking about AI and cybersecurity. Now let's move on to a topic that's really captured everyone's attention lately, large language models. Or LLMs. They can write poems and code and even translate languages. But are they secure?
That is the big question, isn't it? LLMs are still a fairly new development, so researchers are only just starting to understand their vulnerabilities.
And one vulnerability that's particularly worrying is data poisoning. Can you explain what that is and why it's such a big threat to LLMs?
Sure, imagine an attacker very subtly manipulating the datasets that are used to train these LLMs by injecting biased or even malicious data. They could influence the LLM's output so it starts generating harmful content or spreading misinformation, and no one would even realize where the problem is coming from. There's a paper that goes into this in depth. It's called Multifaceted Studies on Data Poisoning Can Advance LLM Development.
It's like poisoning the well of knowledge that these LLMs draw from. Scary thought. Are there any other security concerns with LLMs that we should know about?
Well, there are a couple of papers that explore something called jailbreaking LLMs. One is how jailbreak defenses work in Ensemble, a mechanistic investigation, and the other is making them a malicious database, exploiting query code to jailbreak aligned large language models.
Jailbreaking, so tricking the LLM into ignoring its safety protocols and potentially generating harmful content.
That's exactly it, like finding loopholes in the LLM's programming to make it do things it's not supposed to. And of course, there are researchers working on defenses against these jailbreaking techniques. But then the attackers find new ways to get around them. It's a constant back and forth.
It really does sound like a cat and mouse game.
It is.
And then on top of all that, there's the issue of LLMs generating code that might have its own security vulnerabilities. That's what the paper Backbench, Can LLMs Generate Correct and Secure Backends, is all about?
Yeah, it's a complex problem with a lot of different angles. LLMs have so much potential, but we have to be aware of the risks and actively work to minimize them.
So what's the bottom line for the average person who's just trying to navigate all of this?
Be aware. Remember that these models aren't perfect. They can make mistakes. So be critical of the information they generate, especially when it comes to sensitive topics. And don't just blindly accept everything an LLM produces as the absolute truth.
Good advice. Now let's switch gears a bit and talk about another crucial area, privacy in a data-driven world.
Right. In today's world, protecting our privacy is harder than ever. But thankfully, there are researchers working on new and creative solutions to protect our data without stopping innovation.
Okay, well, let's dive into those solutions and the research behind them. After a quick break, stay with us.
One really promising approach to privacy is coming out of a paper called A Note on Efficient Privacy-Preserving Similarity Search for Encrypted Vectors.
The title's a bit of a mouthful.
It is a bit jargony, isn't it? But basically, imagine searching for something without revealing what you're looking for. So this research is all about techniques for performing searches on data that's been encrypted.
So kind of like finding a specific book in a library without anyone knowing which book you're after?
Yeah, exactly. You get the information you need, but without compromising your privacy or exposing any sensitive data.
Interesting. What other privacy-preserving techniques are out there?
There's another one that looks at analyzing user data, but without actually accessing individual data points. It's explored in a paper called Learning from End-User Data with Shuffled Differential Privacy Over Kernel Densities.
So like identifying patterns in a crowd, but without being able to pick out any one person.
Exactly. So with this technique, they add noise to the data set, but in a way that preserves the statistical properties, so researchers can still get valuable insights without compromising anyone's privacy.
Pleasure. Like studying the behavior of a flock of birds without having to track each individual bird.
That's a great analogy.
But even with all these privacy-preserving techniques, attackers are still out there, coming up with new ways to find and exploit vulnerabilities. What kind of emerging threats are researchers seeing right now?
Well, there's one paper that's looking at a new way to find vulnerabilities in computer processors, using something called reinforcement learning. It's titled Discovering Transient Execution Vulnerabilities Using Reinforcement Learning.
Hold on. AI-powered vulnerability discovery. That sounds a bit counterintuitive. How does that even work?
So it's like this. They train an AI agent to play a game where the goal of the game is to find and exploit vulnerabilities in a processor's design. And by constantly testing different attack strategies and learning from its successes and failures, the AI gets really good at uncovering hidden flaws.
So like having an automated white hat hacker that's constantly probing our systems, trying to find weaknesses so we can fix them before the bad guys get there.
Exactly. Proactive vulnerability discovery could be a real game changer in cybersecurity.
And aside from those complex attacks, what about the more everyday threats, the ones that target regular users?
Yeah, those are still a big concern. And there are a couple of papers that highlight the growing problem of browser fingerprinting and audio deepfakes. One's called Browser Fingerprint Detection and Anti-Tracking, and the other is Pitch Imperfect, detecting audio deepfakes through acoustic prosodic analysis.
Browser fingerprinting, that's where websites can track you online, even if you're using privacy-focused browsing modes, right?
Right. Blocking cookies and using private browsing helps. But even then, your browser configuration can reveal a lot about you, like what plugins you have installed, the fonts you're using, even your screen resolution. And all of that combined creates a unique fingerprint that can be used to track you across different websites.
It's kind of creepy when you think about it. And what about audio deepfakes? It feels like we're getting to a point where we can't even trust our own ears anymore.
It is worrying. With these new AI techniques, attackers can make incredibly realistic audio recordings of people saying things they never actually said.
This is like digital puppetry, creating fake audio to spread misinformation and manipulate people. How can we even defend ourselves against that?
Researchers are developing tools that can analyze audio to detect deepfakes, looking for tiny inconsistencies that give them away. But honestly, the best defense is probably our own critical thinking skills.
So being skeptical, checking information from multiple sources, not believing everything we see and hear online.
Absolutely. As the threats become more sophisticated, our ability to tell what's real and what's fake becomes more and more important.
Okay, so let's shift gears a bit. With all these cyber threats out there, what kind of skills do we need to effectively protect ourselves and our organizations?
So it's a paper called What Skills Do Cybersecurity Professionals Need? And it offers some really valuable insights. Obviously, technical expertise is still essential, but the paper also emphasizes the growing need for professionals with a broader range of skills.
So not everyone needs to be a coding genius.
No, not at all. Coding is important, but communication skills are just as crucial. Cybersecurity professionals need to be able to explain really complex technical concepts to people who aren't technical, both within their organization and to the public.
So being able to bridge that gap between technical jargon and plain English is key.
Exactly. And they also need good project management skills to handle complex projects and lead teams effectively. Cybersecurity is a team sport, so being able to communicate and collaborate well is really essential.
So it's more than just firewalls and antivirus software these days. It's about managing risk, having a comprehensive strategy, and making sure everyone understands their role in protecting sensitive information.
That's right. As we become more and more interconnected, the human element of cybersecurity is only going to become more important.
Well, this has been a whirlwind tour of the latest cybersecurity news. We've talked about vulnerabilities, defenses, and the skills we need to navigate it all. Now let's wrap things up with some final thoughts and key takeaways. So welcome back to our cybersecurity deep dive. We've covered a lot of ground today, from critical infrastructure to AI to privacy in a data-driven world.
It's a lot to keep track of, for sure, but I think the biggest takeaway from today is this. Cybersecurity is all about people. It's about protecting our data, our privacy, our digital lives.
Absolutely. Technology is obviously important, but like you said, it often comes down to the human element, whether our defenses are effective or not.
Exactly. So we need to be informed, we need to think critically, and we need to be responsible digital citizens. And we also need to support the development of technologies that are both ethical and secure, that prioritize user privacy and safety. You know?
Makes sense. Well, in today's deep dive, we've seen some of the latest research on securing critical infrastructure. We talked about AI and how it can be used for both good and bad. And we looked at the challenges of LLMs and, of course, the need for privacy solutions in a world driven by data.
Yeah, we covered a lot. And while the threats are definitely getting more sophisticated, so are the defenses. Researchers are working hard to come up with new ways to protect our data, our systems, and in the end, our digital lives.
It really is a constant evolution. And that just highlights how important it is to stay informed and to be adaptable. Knowledge is power when it comes to cybersecurity. The more we understand these threats, the better we can navigate this increasingly complex digital world.
Couldn't agree more. Cybersecurity is a shared responsibility. We all have a role to play in making the digital world more secure and more trustworthy. So stay curious, stay informed, and stay safe out there.